All right, everybody, let's get started. This is our last required lecture in Engineering 102 and our last required meeting of the semester. Okay, so a couple housekeeping items. First off, attendance. I haven't updated the attendance for Wednesday or obviously for today, but after today, this is the last day that I'll be collecting attendance in the class. So after today, I'll just update everything and then you'll have your attendance grade locked in for the semester. Okay. In terms of assignment gradings, obviously the first two exams are done and over with for the remaining assignments. So assignment 12 has been graded. The grade very well. Average was an 88, so y'all did fantastic. For assignment 14, that's the stress analysis assignment. Most of you had done that by the start of this morning. So just make sure and get that assignment done by 5 p.m. That one's due at 5 p.m. today. Okay. After assignment 14, the only two things you have left in this course are the final assembly and the bonus homework. The bonus homework is where you do the course eval. Okay. Now I was looking on Blackboard and then in MyMU. I have no idea who submitted what. The only thing I know is how many people submitted. So as of this morning, 78 students in the class had done their evals, but only 64 of you had uploaded proof that you have done it. Again, I don't want to see what you've done, but if you upload a screenshot that you did it, you get 10 bonus homework points. And again, you can say I'm a poopy head, you can say I'm the worst professor ever, that's fine. I do really want your feedback. Again, as I mentioned before, this is only my second time teaching the class, and this is a really large and really important class. So any suggestions you have, either for me or for future faculty teaching the class, it really does help us out. So we really do appreciate you taking the time to fill that in. So much so that I'll add 10 bonus points on your homework average when it's all said and done. So if you haven't done it, please do it. But homework 14, the course evals, and the final assembly, that's all we got in this class, okay? So everybody good? All right, did everybody get the QR code for attendance? Okay, all right. So today what we're going to do is we're going to do our final assembly, okay? So a couple things about that. If you go to Blackboard, okay, let me open up Blackboard. Okay, so this is Blackboard. I'm going to go to Student Preview. Okay, so this is what it looks like for you. Okay, if you go to Week 15, here at the very bottom, go to Assemblies, go to Tutorial. These are the 4-part files you need to download, okay, for the assembly today. We're going to be doing the wheel assembly together. The final assembly you all, or the vice assembly you all will work on your own. If you're using Cameo, stick these in a folder in your OneDrive, okay, because you need to access them via the MS folder. If you're working on your desktop, just put them wherever, just as long as they're easily accessible. I stuck mine on the desktop for this, okay? All right, so what we're going to do today is we've created 2 of these parts together. I imagine you could create the other 2 on your own. What we're going to do is assemble them. So the way that works in Inventor is we create what's called an assembly file, and then we create several instances of those assemblies, and then we then stitch them together. So we're going to have 4 parts, but we will have 5 instances. Okay, because 2 of those parts, the angle bracket, we're going to use 2 instances of. Okay, so let me go ahead and open Inventor. Okay, so I've got Inventor open here. I'm going to create a new assembly. We're not creating a new part, we're creating a new assembly. So that's down here. We're going to create a standard metric assembly. We're going to hit create, and then we're going to let this do its thing. Again, if you're running Cameo, download the 4-part files, stick them in your OneDrive, okay? All right. Now, a couple things about the assembly interface. So if you look up here, it is slightly different. We have an assembly or an assemble tab. We didn't have that before. So essentially what we're going to be doing is inserting instances of these parts, okay? Now, for the purposes of this assembly, it does not matter, and really assemblies in general in Inventor, it doesn't really matter where you place the instances because we can constrain them later. In fact, I actually think it's kind of a good idea to scatter these things apart. Okay, so what I'm going to do is, first off, I just realized something. I need to replace my parts here because I think I changed those in the last lecture. Yes, I did. So let me copy these. delete these, and then paste them. So I have fresh parts I'm working off of. Yep, I need to do that. Okay, so I'm going to place. So what we do is we place an instance. We click the little place component option right here. We navigate to wherever this is. So I put these on the desktop. So if you go to the desktop, I have a folder called Starting Files. Okay, and what I'm going to do is I'm going to start by placing an instance of the base plate. So when I hit open, Inventor's like, okay, where do you want to put it? Okay, I can put it wherever, so I'm just going to click right here. And when I click, I've placed the instance. Now, if I keep clicking, what I'll do is I'll place more and more instances of the same part. I don't want to do that. So all I'm going to do is hit click and then hit the escape button. Okay, so hit click and hit escape. And in fact, I actually think it's a good idea to kind of zoom out a little bit. I want to give myself a little bit of room, because I'm now going to start placing instances of other parts. Okay, so let's place an instance of, let's say, the wheel. That should also be familiar, and I'm going to stick that sort of like all the way over here. Again, there's no magic as to where you put these things, because we're going to constrain them later. So I'm going to put one right there. I'm going to place an instance of the axle. Stick that, I don't know, right there. And then for the bracket, what I'm going to do is I'm going to place one instance, and then I'm going to click again to place another instance, and then I'm going to hit escape. So in other words, I know I'm going to need two instances of that angle bracket, so I'm going to place it twice inside the assembly. So it's the same part file, but I'm using a copy of it. I'm using two copies of it. That's what an instance is. Now, I'll give everybody a sec on this, particularly for the Cameo folks, to make sure they're able to get it instanced and whatnot. Everybody able to get this instance? Yes. You place it. So, well, you need two angle brackets. So, just delete, go over here, delete the second axle, delete the second base plate, delete the second. All right. Now I want everybody to look up here, just so everybody's aware. You should be able on the screen to click and drag and move these things at will. Okay, that's how it should be working. What we're going to be doing is constraining these parts such that they only move the way we want them to. Okay. Now before we do that, I'm going to start assigning materials to these parts. To be clear, assigning materials doesn't really affect the assembly process at all. And it really only does two things. Number one, it will affect the visuals, because it'll make the instances look like a different color. But two, when we start creating our assembly drawings and we want a bill of materials that references, what material a given part is made of, we do need our materials assigned. Okay. Now I'm going to zoom out a little bit to explain how I'm going to do this. I want to kind of get this to where the parts are sort of like over there. That's probably good right there. Okay, so I'm going to go to Tools and go to the Material tab. So this is the Material Browser. We've used this before because we use this on our stress analysis assignment. For this assembly, everything is made out of cast iron except the axle. The axle is made out of alloy steel. So what I'm going to do is I'm going to load cast iron. So I go into Iron, and I click the little up button on cast iron, and then I go to alloy steel, and I click the little up button on alloy steel. So essentially I'm loading into my assembly the two materials that I'm going to need. But I'm not going to close the material browser. I want to leave that open. So you can see I've got the material browser on the left, and I've got my instances on the right. And all I'm going to do is click a material, click an instance. Or sorry, other way around. So click that, click a material. Click the axle, click the alloy. Now what happens with the brackets, if you click the bracket and then click the material, what happens is it actually assigns the material to both instances. Because what we're actually doing is assigning material characteristics to the parts not the instances. So when you assign materials to a single single instance, you're actually assigning it to the part, so it affects every instance. Okay? So we'll hit close, hit our little home button. And so now, if you do this right, what you should find is that every part in the assembly has sort of a dull black hue to it, other than the axle, which should be kind of shiny and whatnot. Where are your tar shovels? No, the files. Oh. Because it's possible they're in a file. All right. Eyes up here. Is everybody at this point, does anybody have any issues placing your instances or placing your material applications? Anybody having any issues? Raise your hand if you are. Who said?
It was dropped down to like a song menu instead of a place for
You got it now?
Yeah.
Okay.
Is there something about like converting from
All right, everybody, eyes up here. Okay. So if you look here in your screen, okay, like I said, you should be able to drag and drop parts as needed, okay? Because there's nothing that Inventor is doing to lock positions. What we're going to need to do now is to lock positions, okay? Now, I want everybody to be clear. We are going to have to do a lot of rotating of the screen. So a lot of like, you know, looking at the assembly this way and looking at it this way and rotating it this way, okay? So make sure that you're comfortable with using that cube in the top right because we are going to use it quite a bit, okay? Now, the way that we're going to do this is we're going to apply what are called assembly constraints. Now, assembly constraints affect how the geometry of given parts behave against one another. And what we often have to recognize, or what we're often doing when we place constraints, is we're using what are called parent-child relationships. Now, in Inventor, what that means is that you start off by placing the first end of your constraint with the child, and then the second end of your constraint with the parent. So the idea is that if you're moving parts, the child has to respect the movements of the parent, okay? So the way that we're going to do this is we're going to start off by attaching these angle brackets to the base plates. Everybody watch up here. So I'm going to place a constraint, okay? Now this window pops up. There's a number of different ways you can do this, like assembly, angle, tangent, and so on and so forth. We're just going to go with the base one. And what we have to pick is a child and then a parent. Okay, so the child, so here's what I'm going to do. For the first, I'm going to use this angle bracket right here to the base plate. So I'm going to zoom in, and I'm going to pick this axis. Now I want to be clear, when you place this constraint, what you have to do is you have to pick the axis. Don't pick the circle or a point on the circle, pick the axis, the actual line going through the center of the circle. And then I'm going to place another constraint right here through the center of this circle. And when you hit OK or apply, so I'll hit apply, and then I'm actually going to close this window. Okay, what you can see is that I've constrained this. Now, if I start moving this part, what's happening is I can move like crazy, but they are locked such that the central axis of the hole on the bracket is locked to the central axis of the hole on the base plate. Again, you have to pick the axis. Don't pick the circle or the dot. Pick the axis because that's what you're locking together. Okay? Now, it might seem a little bit redundant, but I'm actually going to, like I've locked the axis of one hole, I'm going to lock the axes of the other holes. Kind of redundant for this bracket, but it's not going to be redundant for the next one. Okay? But I'm going to do that by rotating around so that I can see both. So constrain that to that and hit apply. Now, now the problem is the surface, it's fine that I've got the holes aligned, but I want them to come into contact, okay? And so the way that I'm going to do that is with a surface constraint. So essentially, here's my angle bracket, here's the base plate. I want to constrain this surface to that surface, okay? So what I'll do is I'll rotate to where I can see the bottom of this, rotate to where I can see the top of that, and then when I hit apply, now those two surfaces are into contact with one another, and now if I go back to my home view, now they're mated up, which is actually what I wanted, okay? Now, I'm going to do the same thing with the other angle bracket. The problem is the angle bracket's turned around, it's turned the wrong way, okay? And so that's where aligning both holes is going to come into play. So what I'll do is I'll constrain this axis. Now you got to be careful, got to pick the right one. We're going to constrain that against this one. And then again, I find it a good idea to actually sort of drag these away to where it's kind of easy to see what's going on. Then what I'll do is I'll constrain here. Let me rotate this thing around. I'm going to constrain this hole with this one. Okay, again, make sure you click the axis. Don't click the circle, don't click the dot, click the axis. Hit apply. And now you can see the angle bracket's now facing the right way. The only thing left to do is to mate the surfaces. So we'll constrain that surface to that surface. Now it's starting to look a little bit more like a wheel assembly. Okay? Y'all see what I did there? I'm going to give everybody a second on that. I'm going to walk around and see how everybody's doing. Your question?
You're just like thick and not on.
What?
The bottom of the base plate.
Hit escape. You haven't constrained yet. See, the reason it's not fixed because it's sort of in there. So what you need to do, like, you need to make that surface to that surface. I'll show you something. If you go to view, see where it says row style? You're doing shaded. When you shaded the edge, you can actually see.
I could not see what was going on.
That happens sometimes. Depends on your computer's rendering. So. Yes. You make the other hole. Have you done any constraints? So what happens is, okay, see how I line that hole? Okay. So now I can drag like crazy, but watch what happens when I constrain this hole, that hole. See what Inventor's saying, how would you know this? You see what I mean? Yeah. So instead of trying to rotate, go, I know this is how it's supposed to go together. That's what we're doing.
That makes a lot of sense.
The actual contact.
You can do either one first.
I find it a little easier to do the axle, but because of the way that we're going to position the wheel.
Like the face.
All right, is everybody good? Okay, eyes up here. Okay, so what I'm going to do, so now that I've got the brackets where they need to be, I'm going to place the axle where it needs to be. And I've got some images here in the handout, which I'm hoping can make that a little easier. But what I'm going to do is I'm going to do an axial constraint and a surface constraint for the axle. Now the way that works is I'll constrain the central axis of this little axle right here against the central axis, let's say, of this hole. So if I hit apply, so now if I move the axis, no matter where I move it, it has to align with the center of that hole. But now I just need to place it where it needs to go. Okay. Now the way that I do that is I'm going to constrain. So it's this surface right here. I have it highlighted here on the handout. It might be a little difficult to see, but it's that little inner ring right there. If everybody can see on the screen, it's that ring, that little blue ring that is supposed to come into contact with the face of the bracket. And what it's supposed to come into contact with is that face right there. Okay. So if you constrain those two and then hit apply, for example, if you look at a front view, you can see that the axle is right where it's supposed to be. Okay. Now we'll do the same thing with the wheel. Okay. So what I'll do is I will constrain the central axis of this wheel hole to the assembly, which is fine, except for the fact that now I can move the wheel wherever it needs to go, but I need to know exactly. So here's the wheel. I can put the wheel wherever I want, but I need to. It needs to go somewhere here. Okay, and so it is for this final constraint that we're going to learn about what are called offsets. Okay. So the way an offset works, so if I have a constraint where part A is to be constrained to the face of part B, and my offset is 0, then they'll be directly in contact. But if I use an offset of, say, 2 inches, what Inventor will do is it'll say, okay, part A is into contact with part B, and then shove them away by 2 inches. Okay? So what I'll do is I'll do that with the wheel. Okay? Because I want that wheel to be perfectly in the middle. Okay? So we'll do another constraint. Let's constrain this face of the wheel with that face of the bracket. And so if I leave everything alone, the wheel is going to be shoved all the way over to the left. I don't want that. See this little box right here where it says offset? So for example, if I make the offset 50, okay, what it's going to say is it's going to say put them into contact, those two surfaces, and then shove them away by a distance of 50 millimeters. Now 50 millimeters is too much, but 5 millimeters, that's right on the money. Now that 5 millimeters puts that wheel right in the middle. Okay? So I hit OK, hit the home button, and by golly gosh gee, there's my assembly. Fully set up and ready to go. What? I don't know. It's crazy.
I know I didn't do it.
I know. Although it's probably given us, you know, I'm not worried about it being perfect in position. It'd be
Yeah, it's good.
It's like, you're always talking. I'm just it's like,
We don't think, we don't.
So it doesn't have a bearing and it's elemental.
Oh, yeah, and there's no, like,
Wells themselves together.
yeah, there's no gaps, because they're all perfect. So they won't even move.
So there's a, something wrong. Yeah, and it's this clip right there. No, so you line the axes up, right? But it's this surface right here.
They could work with
Yes.
if you, if we had clear, because
We needed to access the
$34 less. Fort Mitchell, Kentucky, you know how far away that is?
You've got something wrong here. You did you made it.
Marketplace service dropped their journey together to, well, from $185 to
All right, everybody. Okay. Yeah. Oh.
Yes. The axis. There you go. Then, no, don't do the offset yet. Just hit apply. Now, what you can do is, this is, oh, you're missing something. You're missing something. So, but what I'm saying is you can make like that surface with that surface. But you're missing some, that's why it's not fully together. So,
All right. One more, and then I want to get to assembly drawing.
Where are you? Are they in the actual
select. Every time he clicks up, it's just going to click and then look.
Okay, so this is probably so what I'm going to do is take extra. Where are you? So what I'm going to suggest is y'all do this you may need to like save your assembly something with your
All right, everybody. Okay, eyes up here. All right, so the last thing I want to show you is how to do assembly drawings. If you have not started the drawings for your vise assembly, I've got something that can save you a little bit of time, okay? So eyes up here. Okay, so now that I've got the assembly created, I'm going to file, save as, and I'm going to put this, I'm going to call it wheel assembly. Now, if you do this, it's possible you get an error message that looks something like this, okay? This is okay, all right? But I'll explain what's happening. When we opened the assembly, we actually changed some properties of the native part files. By the way, what properties did we change for the part files? What? The materials. We assigned materials to the part files. And so Inventor's going, wait a minute, like, is that what you wanted to do? Yeah, that's fine in this case. So we'll just hit yes to all and okay. But basically Inventor's saying, yeah, you changed the assembly, but you also changed the part files as well. So if you get that warning, that's okay. Now we're going to create a new drawing. I'm going to save it. Call it wheel assembly drawing. And before I move on and start actually placing some views, okay, I'm going to change my eye properties to just sort of get all the formatting stuff taken care of. We'll make the author UABC. Make the company Marshall University CECS. Project Engineering 102. And then for the status, make this GKM, make this GKM. Hopefully that part is pretty quick because we've done that before. Okay, so basically what I'm doing is I'm affecting that title block there at the bottom. Okay, and then what I'm going to do is I'm going to edit the sheet size to be a sheet size B. And I'm going to use the smaller title block. All right, I am hoping that everybody knows how to do this, right? Now, I just did this for this problem. How many drawings do you have to do? 5? I don't know about you, but I don't want to have to do this 5 times. Okay? So instead of creating 5 individual drawings, what I can use is this single drawing file. And then if you go up here to where it says new sheet, I could just create new sheets and put all of the drawings in this one file. Okay? The benefit of that is that there's a lot of stuff that instead of doing it 5 times, I only have to do it once, okay? And I'll show you what I mean by that. Now, what I'm going to do is if I go into sheet 1, so I'll just double click sheet 1, I can start placing assembly views, okay? Now, how do I do that? Well, it's the same way I've been doing it. Go to the base. I'm going to go right here where it says assembly. The scale for this assembly, I'm going to use a 1:2 scale. And maybe what I'll do is I'll put an ISO view. Stick that up here in the corner. Hit OK. There's my ISO view. Okay. Let's do a front, top, and side. Here's my front. There's my side. There's my top. Now, I don't know if you noticed, but it's rendered it. It's given it shading. You can affect that really easily. All you have to do is double click the view over here on the right, or on the left. So we'll click that, turn the shading off, hit OK. Double click, turn the shading off, and so the shading is right here. Just turn that off, hit OK. Turn the shade off, hit OK. By golly gosh gee, there's my assembly. Okay. Then what you can do, watch this. Then what you can do is, here's my assembly drawing. I can go to sheet 2 and start doing part drawings. How do I do that? I place a view, but look right here. So let's pay attention to what's going on right here. So it's saying place a view, but basically see where it says file, it says place a view of what? Well, I'm placing a view of the assembly. If I click this little folder button right here, and I navigate to where my files are, maybe the MS drive on the X folder or wherever you place them, I'll go to starting files and do like the base plate. Maybe at a 1:1 scale. Stick that right there. Boom. So now I can have all of my drawings in one file. If you have already, by the way, everybody pay attention. If you have already started doing your part drawings for the vice assembly, no big deal. You don't have to do this, okay? So I imagine some of you have already started doing it. That's okay, okay? I don't care if you submit 5 PDFs, 1 page apiece, or a single PDF with 5 pages apiece. That's fine either way, okay? But if you have not yet started doing your part drawings, this is a lot faster, okay? Because you can do all the formatting all at once, okay? And plus it numbers the sheets for you. Now, the only other thing I want to show you if we go to sheet 1, I haven't yet showed you how to do a bill of materials. Okay? So a bill of materials is a list of all the parts that goes into the assembly. Okay? So the way that I do that, this is an annotation. So I just go into the annotate tab. Okay? And if you look here, they call it a parts list here in Inventor. So I'm going to click parts list. Now, when I create a parts list, it's asking, what am I creating a parts list off of? Okay, so all I need to do is just select one of these assembly views, hit OK. Hit OK. And you'll notice this little box pops up. Here, I'll just sort of stick it right there. And there's my bill of materials. Now, my bill of materials really isn't formatted the way that I would like. I'm going to affect that formatting here in a second. Okay? Because I want to see materials and I want to see part titles. So, but it's doing something right, because if you look, there's one instance of each part except for item number 4, and there's 2 instances of that part. Okay? So I'm going to right click and I'm going to go edit parts list. And so I get this little dialog box right here. And so what it's doing is, here's all the columns and whatnot. I'm going to go right here to the very left where it says column chooser. And when I go to column chooser, I get this thing. So what I'm going to do is, it's showing item, quantity, part number, and description. I don't want the part number and description. Instead, I want the title and I want the material. So I'm essentially removing those 2 columns and replacing them with the ones that I want. So this bill of materials, I can have it say whatever I want. Hit OK. Now, not only does the parts list get a little smaller, but now it's showing what I want it to show. Okay? Which, by the way, the one thing that does sort of slightly irritate me is the fact that the materials are not all caps, but that's okay. That's not a big deal. I'm not going to worry about that for your assignment. Okay? All right, does that make sense? So let's just sort of recap something to close out this class and to close out this semester. Okay? So I want to pull up the final assembly. Okay. So this is your final assembly. And these are the final assembly drawings. Okay? I can move this over here. All right, so first off, your task for the final assembly is to recreate every page in the final assembly drawings except page 1. Okay? I'm not going to worry about you doing the exploded view. I'm just not really worried about that for the purposes of the class. So I want you to do this, 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 and this. Okay? With all the annotations, the text, everything that goes on there. That's what I want for your final assembly. Okay? As for what you submit, okay? So this is the handout that I gave you on the assignment. If you look at the very bottom, I gave you an upload checklist. Okay? So this upload checklist, this is what I want you to upload. You're going to upload a Vice assembly file. You're going to upload 5 part files. And you're going to upload your drawings. If you do the drawings the way that I just showed you today, you're going to have a single PDF with 5 sheets. If you have already started creating drawings, you will probably have multiple sheets, like 5 individual PDFs. I don't care. You can do either one. It doesn't bother me. Okay? Especially because I know some of you have probably started to chip away at that. That's okay. All right? But that's due when? Next Wednesday at 5 p.m. Okay? All right. Couple quick housekeeping items, and then I'm going to close this out. Okay? Because I know we're getting itching to leave. All right? So I will be here on Wednesday. It is a voluntary day. You don't have to come if you don't want. I've decided we're going to go ahead and just meet in this room, namely because I don't know how many people are coming. So we're going to go ahead and meet in this room. If you want to come, if you have any questions, come by. If not, don't worry about it. It's not required. I'm not taking attendance. But if you come here, we're going to troubleshoot and Q&A your project. That's the whole, or your final assembly. That's the whole point of what we're meeting for. I'm going to pull the QR code up one more time, but last but certainly not least, there is a good chance this may be the last time that I see you all because this is our last required lecture. It's been an absolute blast having everybody in class. Please don't forget to do your course evals, everybody. But if this is the last time I see you this year, have a wonderful summer. We'll see you when you come back in August. That's all I got, everybody.